Hey, on the further maths A level, there are two different types of vector product that you need to be able to calculate. The vector dot product, which takes the coefficients of the I, multiplies them together, sums it with the coefficients of the product of j, and sums that with the product of the coefficients of k. That gives a scalar, so that's also known as the scalar product. The other product you need to know for this course is called the vector cross product, and it's subtly different. Because when you multiply these two vectors together, you get a vector as a solution as opposed to a scalar. So the reason why this is on the second year of the further maths course is because actually this vector product isn't particularly easy. There's a lot going on. So I'm going to derive the basic concepts for you and then give you the general rule and then show you a quick way to get to the solution. So the idea is that we're going to take these the three unit vectors I, j and k, and what we're going to do is we're going to say I cross j is equal to k. Now what's happening here is we are moving in a 90-degree angle from I to j. Once you've moved that 90-degree angle, turn your face 90 degrees to the left and then follow the 90-degree angle again, and that gives you your solution. Okay, so we've moved 90 degrees from I to j, turn 90 degrees to your left, so you're facing k, and then move 90 degrees down in that direction, and that'll give you your solution. And that's true for all of these definitions. So we also have, if we do, let's go j cross k, so I've moved from this direction down to this way, so I'm facing vertically downwards, turn my head 90 degrees, so I'm facing I, and then come that way by 90 degrees, and then I'm in the I direction. So therefore j cross k equals I. Similarly, I could do k cross I equals j. Okay, so they're kind of cyclic. So again, that's me turn 90 degrees around here, turn my head 90 degrees, so I'm facing j, and then go up. But if I do it the other way around, so j cross I, then I'm going to be facing towards I, move 90 degrees, so I'm going down, turn my head to the left, and then move 90 degrees. I'm actually going to be facing away from k, and this gives me the result that j cross I is minus k. So what we find is in vector cross product, we have an anti-commutative property, which means that a cross b equals minus b cross a. Okay, and that's true always. So that's j cross I. I could do k cross j. Okay, so I move up, turn my head 90 degrees, go down, so I'm facing the negative I direction. And similarly, I could do I cross k. And I'll get minus j from that. The other three that we need to be aware of are the cross products with themselves, and they actually come out to be the zero vectors. Because you've not moved anywhere, so when you turn your head 90 degrees, you don't move anywhere. So you haven't gone anywhere. That's one way to look at it. That gives us these 9 results. So these are the kind of fundamental results, and we're going to use these to derive the general case. So let's take a general case then. So vector A is going to be A1, A2, A3, and vector B is going to be B1, B2, B3. And what we're going to do is we're going to cross product these together. So it's going to be A cross B. That's going to be equal to A1, A2, A3 cross B1, B2, B3. So I'm going to put this into component form as opposed to column form. So that's going to be A1 in the I direction plus A2 in the j direction plus A3 in the k direction. That's the vector A. Going to cross that with the vector B, which is B1 in the I direction plus B2 in the j direction plus B3 in the k direction. And now we're going to multiply the brackets. So that times that, that times that, that times that. Keeping the order in which we are cross multiplying. So I cross I plus A1 B2 I cross j. because it's the I times the j this time, plus A1 B3 I cross k. So the I is times by the k, so it's got to be I times k. Okay. And we could continue across all 9, so that's just the first term on the left bracket. We could then do the second term on the left bracket, and then finally the third term in the right bracket to give me 3 others. That gives me this expansion. That's the expanded bracket. Now what we can do is we can take these cross products and we can simplify them according to our 9 definitions on the first page. So anything crossed with itself is just 0. So these 3 disappear. I times j is k. I times k is j. J times I is minus k. J times k is I. K times I is j. Sorry, that's actually minus j there. And k times j is minus I. Okay, so we end up with those vectors. So simplifying that, we can then say that A cross B is equal to, take the coefficient of I, we've got A2 B3 minus A3 B2 in the I direction. In the j direction, we've got A3 B1 minus A1 B3 in the j direction. And in the k direction, we've got A1 B2 minus A2 B1. And that is the cross product. There we go. That's the general rule. Okay, so cross producting any 2 vectors, and we end up with this vector here in terms of all our coefficients of A and B. So that looks a little bit complicated to remember. Well, fortunately there is an easier method. So I'm just going to quickly show you this one. A1, A2, A3 cross B1, B2, B3 is actually equal to the determinant of a certain 3x3 matrix, which is IJK, A1, A2, A3, B1, B2, B3. Okay, so the determinant of a 3x3 matrix. So what we're going to do, just to remind you if you haven't met this already, and I've not done a video on this course yet, but the coefficient of I is going to be that times the determinant of its minor. So the minor is when you delete I's row and column. So it's the determinant of this 2x2 matrix left down here, which is A2 B3 minus A3 B2. J, this is in a negative position, so it's actually minus. Again, multiplied by the determinant of its minor, so delete the column, delete the row, we're left with this matrix. So that is A1 B3 minus A3 B1 J. And in the k direction, this is in a positive position. Delete the column, delete the row, we're left with this minor here. So that's A1 B2 minus A2 B1 K. And that is the same result as we had up here. Of course, we've got a minus kicking around in there, so we can neaten that up. B2I, do a plus and swap these around, so I'm bringing the minus into the bracket. I'll get A3B1 minus A1B3J, and then plus A1B2 minus A2B1K, and that is the cross product. Another thing to note with the cross product, if A cross B equals the 0 vector, then this implies that A and B are parallel. Converse is also true. I'm not going to prove this. I might prove it in a later video, but I'm not going to prove it today. If A cross B are parallel, then that means that the cross product of those two will be the zero vector. You can only apply the cross products to three-dimensional vectors. You can't apply it to two-dimensional vectors without going into the third dimension. And you cannot apply it to higher than 3 dimensions. It is a vector product which is solely for 3 dimensions. Thank you for watching.